Hello everyone. I welcome you all to the live session on Data Warehouse by Intellipaat. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. Now let's see the agenda of the day. Firstly, we will begin with Introduction to Data Warehouse. In that, we will be explaining you what is data warehouse, what are the types of data warehouse, and also tell you what are the popular data warehouse tools. Post that, we will be doing a hands-on demo to show you how data flows in data warehouse. Then we will move on to Introduction to Data Mart, followed by Data Modeling. Then finally, we have covered data warehouse interview questions and answers. So guys, this is the agenda. Now let's begin the session.
What is the need of a data warehouse? So the goal of every business is to make better decisions. And this is where business intelligence comes in. Business intelligence turns the massive amount of data from operational systems into a proper format that is easy to understand so that this data could be analyzed timely and accurately to obtain actionable insights of business and also to bring an effectiveness in our decision making. For instance, in the e-commerce industry, we maintain data about products, customer login credentials, checkout details, and other technical and non-technical information. Now, all of this information would be available in different servers. So we need a system which can combine all this information so that companies can extract and analyze this data in an integrated manner. And that's exactly where the requirement of data warehouse comes into picture. Now let's understand what exactly is a data warehouse. So the concept of data warehousing is pretty simple. Data is extracted on a periodic basis from source systems, which could be applications such as ERP, CRM, sales, finance, and so on. Now, data from these systems is moved to a dedicated server that contains a data warehouse. So when the data is moved, it is cleansed, formatted, summarized, and supplemented with data from many other sources. And this resulting data warehouse will become the main source of information for report generation and analysis via reporting tools that can be used for things such as ad hoc queries and dashboards. Now, sometimes it has been noticed that many companies say they have a data warehouse, but they don't really have a true data warehouse. Rather, it is actually a dumping ground for tables that are copied from source systems with little modification. So for a company to be successful in future, they must make good decisions. And to make good decisions, they require all relevant data to be taken into consideration. And the best source for that data is a well-defined data warehouse. So a data warehouse is specially designed to perform business intelligence activities and enables professionals and employees to comprehend and improve the organization's overall performance. And the two major functions of a data warehouse are to maintain past and present records and also help organizations to take effective business decisions with precise data analysis. Additionally, the data warehouse environment also supports ETL, data mining capabilities, statistical analysis, reporting, and OLAP tools, which help in interactive and efficient data analysis in a multifaceted view. Now we'll look at some of the key features of data warehousing. So number one in the list is subject oriented. So data warehousing gives you an option to analyze a particular subject area. Thus, a subject matter expert can answer relevant questions from the data. For example, if that particular subject is sales, then a sales executive for an online website can develop a subject-oriented database, including the data fields he wants to query. So the salesperson can extract data, writing different queries like how many customers purchased the database architect course today. And next in the list is integrated. So a data warehouse supports consistency by arranging data from diverse sources in a uniform and rational format. So it should not allow any conflicts in the field names and other units of measure. Having accomplished this steadiness, we can refer it to be an integrated warehouse. The third key feature is non-volatile. So as the name suggests, non-volatile data warehouse refers to no data change once created. It is an important and relevant feature since the aim of developing a warehouse is to evaluate what has occurred until then. And the fourth key feature is time variant. So the data collected in a data warehouse is identified with a particular time period. So this data provides information from the historical point of view. For example, one can retrieve data from the past 3 months, 6 months, 12 months, or even older data from a data warehouse. So now we'll look at some of the most frequently used terms in data warehousing. We'll start with metadata. In simple terms, metadata provides the answers to all your data related questions in the data warehouse. It is referred as data about data. So it gives users a detailed explanation of the syntax and semantics and describing all relevant attributes of the data in the data warehouse. For instance, the number of tables in a database can be referred as metadata. Now, the metadata is also commonly known as table of contents for the data, data catalog, data directory, data warehouse roadmap, and the nerve center. So with the help of metadata, developers and database administrators can create their own ad hoc reports, which is of prime significance in this era of big data. In fact, without metadata, the data warehouse is considered futile. It would just be a big box without any valuable and meaningful information. Then we have OLAP, which expands to online analytical processing. As the name suggests, OLAP is computer processing which allows users to interactively analyze multidimensional data from multiple prospects. The various techniques of multidimensional model of OLAP constitute and encapsulate large volumes of data for rapid evaluation using online analysis tools. In a multidimensional environment, each attribute of data is considered a separate dimension, and OLAP can establish an intersection between these dimensions. So, the OLAP cube is typically similar to the shape of a cube, and it is the multi-dimensional representation of data which is optimized for data warehouse. It is an array or matrix of facts and dimensions, wherein a fact table contains facts or measurements, and the dimension table contains attributes or dimensions of the fact. It is useful when businesses require presenting a spreadsheet containing 2 or 3 dimensions. For instance, in this image, the data is summarized with respect to time, department, and store value. Then we have dimension and dimensional model. As we already know, a dimension refers to single attribute of the same data type. For instance, year, month, minute, and second are all divisions of time attribute. Thus, data warehouse supports dimensional model that enables users to store and analyze information on each dimension. Unlike entity relationship model, dimensional model does not involve a relational database every time. This type of modeling technique is useful for end user queries in data warehouse. Then we have extract, transform, and load, which refers to movement of data from one location to another. Next, we have drill down, drill up, drill across, and drill through. So, drill across allows data analysis across multiple dimensions, while drill up allows data analysis up to the parent attribute, and drill down allows data analysis down to the child attribute. And finally, drill through helps in analyzing data from an OLAP cube to the relational database. Then we have data marts. So a data mart is a subsection of data warehouse which is aligned to a specific business perspective. While a data warehouse stores detailed information of multiple subjects, the latter focuses on storing data about only one subject. And the data mart concentrates on storing more summarized form than complete data and integrating information within specific set of source systems. Now let's move further and discuss some of the major differences between OLAP and OLTP. Generally, people get confused with OLAP and OLTP. They are two different types of data analysis techniques and are distinct from each other in many ways. So here on the screen, we see the collaboration between OLTP and OLAP. In this workflow architecture, we can depict the importance of each system-based application and how they are linked with each other. The first difference is the name itself. OLTP stands for Online Transaction Processing, while OLAP stands for Online Analytical Processing. The main difference between them is that OLTP focuses on small transactions and faster query process. OLAP, on the other hand, often involves complex queries involving aggregations. Another difference between them is that the data for OLTP is mostly operational, while for OLAP, it is consolidated data which comes from various OLTP databases. And OLTP system shows an image of all the activities going on in a business environment, while OLAP system shows different views of individual events. Now that we've understood the concept of data warehouse, it's time to gain some insights into the architecture of data warehouse. So there are two main components to building a data warehouse: an interface design from operational systems and the individual data warehouse design. Thus, the construction of data warehouse depends on the business requirements, where one development stage depends on the results of the previously developed phase. The structure of a data warehouse can be understood better through its layered model, which lists all the main components of the data warehouse architecture. So here is a typical architecture of data warehouse consisting of different important components. You can see that it is nothing but the movement of data from source to the staging area and then finally to the confirmed data march through ETL. The first layer is the data source layer, which refers to various data stores in multiple formats like relational database, Excel file, and others. These stores can consist of different types of data such as business data, web server logs, and internet research data. The next step is extract, where the data from data sources is extracted and put into the warehouse staging area. This extracted data is minimally cleaned with no major transformations. Then comes the staging area, which is divided into two parts: data cleaning and data ordering. So, as the name suggests, this layer takes care of data processing methods, that is, removing data redundancy, filtering bad data, and proper integration of data. Overall, this stage allows application of business intelligent logic to transform transactional data into analytical data. It is indeed the most time consuming phase in the whole data warehouse architecture and is the chief process between data source and presentation layer of data warehouse. Finally, we have the data presentation layer, which is the target data warehouse, the place where the successfully cleaned, integrated, and transformed data is stored in a multi-dimensional environment. Now, the data is available for analysis and query purposes. The information is also available to end users in the form of data marts. This data can then be accessed by various business intelligence tools like Tableau and presented in multiple formats like tables, graphs, and reports. It is important to note that the data warehouse supports and holds both the persistent data that is stored for longer time and also temporary data. The major purpose of a data warehouse is the attainment of cleansed, integrated, and properly aligned data so that it is easy to analyze and present to clients and customers in several businesses. Now we'll understand for what purpose data warehouse is used in various sectors. In the airline industry, it is used for operation purpose like crew assignment, analysis of route profitability, and frequent flyer program promotions. In the banking sector, it is widely used to manage the resources available on desk. Few banks also use data warehousing for market research, performance analysis of the product, and operations. Healthcare also uses data warehouse to strategize and predict outcomes, generate patients' treatment reports, and medical aid services. In the public sector, data warehouse is used for intelligence gathering. It helps government agencies to maintain and analyze tax records and health policy records for every individual. In investment and insurance sector, the warehouses are primarily used to analyze data patterns, customer trends, and to track market movements. In retail chains, data warehouse is widely used for distribution and marketing. In telecommunication, data warehouse is used for product promotions, sales decisions, and to make distribution decisions. The hospitality industry utilizes warehouse services to design as well as estimate their advertising and promotion campaigns where they want to target clients based on their feedback and travel patterns. Now, there are many data warehousing tools available in the market. Let's have a look at some of the prominent ones. So, Oracle is the industry leading database. It offers a wide range of data warehouse solutions for both on premise and cloud. It helps to optimize customer experience by increasing operational efficiency. Amazon Redshift is another data warehouse tool. It is a simple and cost effective tool to analyze all types of data using standard SQL and existing BI tools. It also allows running complex queries against petabytes of structured data using the technique of query optimization. MarkLogic is another useful data warehousing solution which makes data integration easier and faster using an array of enterprise features. This tool helps to perform very complex search operations and helps in querying different types of data like documents, relationships, and metadata. Now, there are a lot of opportunities in the market to build a career in data warehousing. So, candidates who are interested to become data warehouse professionals can look for job opportunities in sectors like information technology, financial services, healthcare, and retail. According to the salary estimates of National Salary Data, which is released by PayScale, the annual compensation of a data warehouse professional ranges from $68,000 to $149,000, with the median salary being about $100,000 per annum.
We'll start with the data warehouse. Let's say, for example, there is an ATM machine. Okay, so here we have one database. Okay, so this ATM machine is connected to the database. Not only ATM machine, so if you have an account with the bank, okay, so we can do online transactions, right? So we can log into our internet banking and then we can also do online transactions. So through ATM machine or any front end application or banking application, if we do any transactions, all the transaction data is going to be inserted into a database. Okay, so whether it is a MS SQL or any other database, so there are different types of databases in market, right? So MS SQL, Oracle, Sybase, DB2, Teradata, like that we have different types of databases. So here, let's say we have a database. So in this database, we will have the tables. Okay, we'll have the schemas. Inside the schemas, we will have the tables like this. So whatever transactions made by the user, all the transaction data, first it is going to be inserted into a database. Okay, let's say an user, he has made the first transaction. So whatever first transaction he has made, the same first transaction data is going to be inserted into a database table, right? Transaction means withdrawing or depositing the money through ATM machine. So the first transaction data is going to be inserted into the database. So after 1 hour, let's say he has made the second transaction, the same second transaction data also is going to be inserted into the database. After 1 hour, he has made the third transaction, the same third transaction data also going to be inserted into the database. So like that, let's say in user, he has made around 1000 transactions in a day. So if he has made 1000 transactions, all the 1000 transaction data should be there in the database, right? Okay, so an user through ATM machine or any front end application or internet through internet banking. So he has made around 1000 transactions in a day. All the transaction data should be there in the database. Okay, end of the day, he has selected mini statement option. So as soon as we select that mini statement option, so this mini statement we have in ATM machine as well as in internet banking also, we have a mini statement option. As soon as we select that option, it is going to generate one mini statement. So that will have some transaction data. Okay. So mini statement will have few transactions or recent transactions will have. The recent means last 5 transactions or last 10 transactions will be there. Okay, so it will not display all the transactions or it will not display the old transactions. Mini statement contains only recent transactions. Okay, so why it contains a recent transactions? Why not old transactions? Okay, because one of the reasons we have, so whichever the database here connected from ATM machine or a front end application, this database itself is designed to maintain limited number of transactions. Okay, so this database itself is designed to maintain limited number of transactions. Limited means, let's say if this database is designed to maintain last 10 transactions, okay, as soon as user made the 11th transaction, before inserting the 11th record in the database, we'll delete the first record from this database table and then we will insert the 11th record. As soon as user made the 12th transaction, before inserting the 12th record in the database table, we'll delete the second record and then we'll insert the 12th record. As soon as user made the 13th transaction, before inserting the 13th record, we'll delete the third record and then we'll insert the 13th record. Like that, if the database is designed, even though user has made 1000 transactions in a day, we will have total how many transactions in the database? We'll have only last 10 transactions, not all the transactions. So why the database is designed like that? Why can't we maintain all the transaction data in this database? Means, suppose let's say the same user from last 1 year, he has made 1 million transactions. So if he has made 1 million transactions, assume we have inserted all the 1 million transaction database in the database. So an user, he has made 1 million transactions and all the 1 million transactions we have inserted in the database. Okay, so inside the database, we'll have the tables. Let's say we have a transaction table. Inside the transaction table, we'll have all the transaction data for one user. Today, he has selected balance inquiry option. So we know there is a balance inquiry option, right? So in ATM machine or in front-end application also, in internet banking also, we have a balance inquiry option. So as soon as we click on that option, what it will do at the back, it will connect to the database. On top of the database, some query will execute, right? So this option at the back, it will connect to the database. On top of the database, some select query will execute. Okay, now for one user, we have 1 million transaction data. Since we have 1 million transaction data for one user, assume to display the balance, the select query is going to execute on top of 1 million transaction records. Okay, so user selected the balance inquiry option. At the back, it has connected to the database. On top of the database, select query is going to execute to display the balance. Now for one user, we have 1 million transaction records. So assume the select query is going to execute on top of 1 million records to display the balance. So if the query is going to execute on top of huge records like this, will it take time or not? Definitely it will take time. So assume it took 5 minutes of time. So user selected balance inquiry option and it took 5 minutes of time. Okay, so why it took 5 minutes? Because of huge transaction data we have in the database. Huge transaction means millions of transaction records we have in the database. So that is the reason query took a long time to display the balance. Okay, like that. So here in the database, if you maintain all the transaction data or huge transaction data, queries will take a long time to execute and it will affect it to the customer. So that is the reason we are not going to insert all the transaction data in this database. Okay, so instead of maintaining all the millions of records, if this database is designed to maintain only last 10 records, in those last 10 records only, if you have all the user transaction details, today, if you select the balance inquiry option, and if you have only last 10 records, query is going to execute on top of only last 10 records, and within fraction of seconds, it is going to display the result, right? So whereas if you maintain huge transaction data, then definitely queries will take a long time to execute. There, it will affect to the customer. So that is the reason we should not maintain all the transaction data. We should have to maintain only recent data or latest transactions in this database. Okay, so latest or recent transaction means last 5 transactions or only last 10 transactions. Okay, now we are clear that so this database contains only recent data. Okay, so recent data or latest data, or we also called it as a current data. So why we maintain only recent data? Why can't we maintain all the transaction data? Means we have seen if you maintain all the transaction data, then queries will take long time to execute and it will affect to the customer. Okay, so that is the reason this database will have the latest data. Okay, fine. Now let's say user requested for last 1 month bank statement or last 2 months bank statement or last 1 year bank statement. Do we have last 1 year data here to generate last 1 year bank statement? No, right? We don't have last 1 year data to generate last 1 year bank statement. Then from where we will get last 1 year data? Means parallelly to this database, we will have one more database. As soon as user made the first transaction through ATM machine or any front-end application, first transaction data, first it will be inserted into the first database. The same first record also going to insert into the second database. As soon as user made the second transaction record first will insert into the first database. The same second transaction record we are also going to insert into the second database. As soon as user made the third transaction record first it will be inserted into the first database. The same third record we are also going to insert into the second database, like that. So if the user has made 11th transaction, we know first database is designed to maintain only last 10 records. As soon as user made the 11th transaction, before inserting the 11th record, we delete the first record and then we'll insert the 11th record, right? Whereas here in the second database, we are not going to delete anything. We will be keep on inserting the records like this. Okay, so if the user has made 1 million transactions, first database contains only recent transactions or last 10 transactions, whereas the second database contains all the 1 million transactions. So here we'll have all the transaction data from day one to till date. So all the millions of transactions we'll have in the second database. So whatever the data here we have in the second database, so this data we called it as a historical data. Historical data means from day one to till date. If we insert or if we load all the transactions, then we can call that as a historical transactions. Okay, so can we call the first database as a historical transaction database? No, because in the first database we have only recent transactions. So here in the second database we have all the historical transactions. Historical means from day one to till date all the transactions we will be keep on inserting the data. We will not delete the data from this database. We will not update the data in the second database. If you delete the data or if you update the data, then we can lose the historical data, right? So we will not have the historical data. So if you delete some of the records here, then how come we'll have the historical data? We will not have the historical data in the second database. Okay, so in the second database here we'll have all the historical data. So whichever the database is having the historical data like this, that database we called it as a data warehouse database. Okay, so in MS SQL also, we will have tables, right? So in that database, we'll have the tables. In those tables, if you insert all the records from day one to till date, then that database also we called it as a historical database. Okay, so now how about the first database? The first database contains the recent data. This database we called it as a OLTP database. So OLTP means online transaction process. So OLTP database contains the recent data, whereas the data warehouse contains the historical data. What is meant by historical data? All the transactions if we insert from day one to till date, we can call that as a historical data, right? Data warehouse contains the historical data. So historical data means all the transactions should be there from a data warehouse, like from day one to till date, all the transaction will be there. Okay, so we'll see what is the use of storing the historical data in data warehouse. Okay, so suppose let's say here we have one more ATM machine belongs to same bank, and this is another ATM machine belongs to same bank. Okay, so let's say this ATM machine we have in HYD location, and this is in Bangalore location, this is in Chennai location. So like this, there are three ATM machines belongs to same bank in three different locations. Okay, so all of these three, first they have connected to OLTP database. From OLTP, so we have connected to the data warehouse database. So all of these three databases we have connected to OLTP database. From OLTP we have connected to the data warehouse database. So which means in data warehouse we have historical data of all these three ATM machines, right? Okay, let's say for example we have the historical data like this. So in the year of 2001, from HYD location machine, we have total 120 transactions. Okay, so from BLR location, assume here we have around 80 transactions. From Chennai location, let's say we have around 40 transactions. Like this, we have whole year transaction data belongs to these three ATM machines we have in data warehouse database. Okay, so let's say in the next year, from this location we have around 90 transactions. From this location we have around 100 transactions. From this location we have 30 transactions. In the same way, we have one more year transaction data. From this location we have around 150 transactions. Here we have some 90 transactions. Here we have 40 transactions. Like this, we have 3 years of transaction data belongs to these three ATM machines in data warehouse database. We know data warehouse contains years of data, right? Okay, so there will have the huge transaction data or years of data will be there in the data warehouse. Okay, next. Since all of these three belongs to the same man, let's say they have some cutoff transactions. If the transactions are greater than 50, that is in profits. If it is in less than 50, that is in loss. So like this, let's say they have some cutoff transactions. Okay, so here Chennai location, this is, you can see this is in loss, right? So if you keep on maintaining like that, already it is in loss, right? Now what you did here, you have some data. By seeing this data, you have done some analysis. Based on your analysis, you have taken the decision on the business to keep the business in profits, right? Okay, so whatever the data here we have, so we can call this as a report. By using which data we have generated this report? By using the data warehouse data, right? So by using the data warehouse data, we can generate the report. These reports are helpful to the business people to do analysis on their business and to take the decision on the business and to keep the business in profits. So if you don't have such type of report, how would we know that which is in profit and which is in loss? We don't know, right? And also, is it possible to generate this type of report based on OLTP data? No, right? So we cannot generate because OLTP database contains the latest data or current data. We cannot take the decision or we cannot generate a report based on OLTP data. So OLTP database contains the recent data. So just by seeing the recent data, like 1 day or 2 days of data, we cannot take the decision on the business, right? So to take the decision on the business, we need to have the historical data. So by using the historical data, we can generate the reports. The reports are helpful to the business people to do analysis on their business and to take the decision on the business. So this is the overview of data warehouse. Okay. Now, so first all the transactions are going to be inserted in OLTP database, right? The same transactions here we should have to insert, okay, into the data warehouse. It's whose responsibility to extract the data from OLTP database, transform and load into the data warehouse. So who will take care to extract the data from OLTP to data warehouse? Means there are different process to maintain the data or to process the data or to load the data from OLTP to data warehouse. What process we have? So that process we call it as a ETL process. So ETL team. So ETL means extract, transform, and load. So ETL, by using the ETL tools, different types of ETL tools are there in market, like Informatica, Data Stage, Ab initio, Pentaho, right? Warehouse Builder, and also like through PLSQL, also we can write the code. Okay, so like that, so there will be separate teams, so they will be taking care to maintain the data between these OLTP and data warehouse. So they will be extracting the data from OLTP database, transform and load into the data warehouse. Okay, once the data loaded into the data warehouse, on top of the data warehouse, reports will be generated. So here mainly ETL developers will be taking care to maintain the data between OLTP and data warehouse. Okay, so while loading the data from one database to another database, there are different scenarios. Okay, for example, let's say in OLTP we have a table like this. Employee table we have. This is a source table. Employee number, employee name, salary. Okay, so here we have the data like this: 1A 100, 2B 200, and 3C 300. Again 1A 100, 2B 200. Now like this we have a employee table. Okay, so if you have employee table like this, and if you observe here, there are duplicate rows. So in a table in OLTP database, we have a table. In the table, we have the duplicate rows. These two are the duplicate rows. Okay. Now let's say we have to load that data from here OLTP to data warehouse. This is a target table. So while loading the data from OLTP to data warehouse, Here in OLTP we have duplicate records. Let's say we have processed all the duplicate records also into the data warehouse table. So if you process all the duplicate records also into the data warehouse table, on top the data warehouse will have the duplicate data or incorrect data or invalid data we will have in the data warehouse. Okay, so if you have the incorrect data or invalid data in the data warehouse, then on top of the data warehouse, we know reports will be generated, right? Okay, so if you have the incorrect data, how the reports are going to be generated? Is it going to be a valid report or invalid report? Definitely, they are going to be invalid report. So that is the reason here generally if there are incorrect records, so the first here the incorrect records to be fixed, and then valid records only we have to extract, transform and load into the data warehouse tables. Okay, so next, so as I told you, we will be loading the data from OLTP to data warehouse, right? So here this is a OLTP database and the data warehouse database. This is OLTP which will have the latest data, and this data warehouse will have the historical data. Okay, now here to this OLTP database, so let's say these are from different locations. So ATM machines are connected. In a country, millions of customers will be there to the bank, and they will be accessing their account details, or they will be doing the transactions from different locations. Okay, let's say all these are ATM machines. They are there from different location. First, they have connected to OLTP database. Okay, and also users, they will be doing online transactions. Let's say these are the internet banking applications. Okay, so like that we have different internet banking applications, so users can log into their account and they can do online transactions. Okay, so we know that millions of customers will be there, and they will be accessing their account details or doing the transactions. Now there is only one database here, which is OLTP database. OLTP means online transaction process, right? So which will have the recent data. So if millions of customers are accessing the OLTP database data at a time from different locations, then definitely there may be chance to go the database performance down, right? So that is the reason, instead of connecting all these applications to a single database, here we will have another database. This is called ODS database. ODS means operational database. Okay, so in MS SQL only we will have schemas. Okay, inside the database we will have schemas. So this is one schema. OLTP is one schema or a database, and this is another schema. This is another schema. Like that, in the same database only, we will be creating different schemas to maintain the data in different layers. Okay, so if this database performance is down, then definitely it will affect to the customer. So that is the reason, instead of connecting all these applications to a single database, some of the applications we will be connecting to the OLTP database, some of the applications are connecting to ODS database. Okay, so here let's say if all the ATM machines are connected to OLTP database, these front end applications or banking applications we will be connecting to the ODS database. ODS is a replica of OLTP database. So whatever tables present in ODS database, the same tables also present in OLTP. Whatever tables present in OLTP, the same will present in ODS. Not only tables or data also, it will be in a sync between these two databases. The data will be in a sync. Okay, so any transaction happen from like inside the OLTP database, immediately that transaction also is going to be updated or inserted or deleted in ODS database. Any transaction happen through this front end application or internet banking, which will be directly inserting into ODS database, immediately that transaction also going to be inserted in OLTP database. Like that, these two databases will be in a sync. Okay, so to maintain the data in a sync between these two databases, jobs will be created. MS SQL or PL SQL or ETL jobs will be created to maintain the data in a sync between these two databases. Again, once the data is available in ODS database, so to maintain the data in a sync between these two databases, again ETL jobs will be created. Here ETL team, they will be loading the data into the data warehouse. Okay, so like that the data flow. So why we have the ODS database means, since OLTP is a sensitive database, we cannot insert all the transaction data in only OLTP database, or all the millions of customers should not access the same database data at a time. So that is the reason, we have here ODS database. Since OLTP is a sensitive database, so if we insert all the transaction data, it will affect to the customer. So that is the reason we have created the replica. So in many of the companies, this replica of the database will be their ODS. So from there, again the data will be loaded into the data warehouse. Next, so another data flow we'll see in data warehouse. So this is OLTP database, right? So let's say this is ODS database, operational data source, and then all the data. So whatever data present in OLTP database, the same data also present in ODS. So immediately there will be some jobs at the back. They will be taking care to maintain the data in a sync between these two databases, OLTP and ODS database. They will be in a sync. So both the databases will be in a sync. Okay. So if there are 100 tables in OLTP, the same 100 tables also present in OLTP and ODS. All the applications are not connected to both the databases. Some of the applications are connected to OLTP database. Some of the applications are connected to ODS database. Okay, and the same data will present in the data warehouse also, right? So suppose let's say here in OLTP database, if there are 100 tables, instead of 100 tables, we'll talk about one table. Let's say in OLTP we have employee table. So in this table, if there are 100 records, same employee table will also have in ODS database. Here also we will insert all the 100 records, and the same employee table will have in the data warehouse. There also will insert all the 100 records. So across these databases, we will load the data. First, data transfer will happen from OLTP to ODS. Once we have the data in ODS database, so there will be some other jobs. They will be extracting the data from ODS, transform and load into the data warehouse. Okay, we'll see this data flow here in this scenario. Now let's say this is OLTP database, and here we have ODS database. Okay, so as I told you, these two will be in a sync. Okay, let's say in OLTP there are 4 tables. The same 4 tables also present in ODS database also. These are the tables inside the ODS. Okay, so this is T1 table, T2 table, T3 table, T4 table. So like that, there are 4 tables in ODS. Okay, now as I told you, here we'll have the data warehouse. So let's say this is data warehouse database. Okay, so inside the data warehouse, we will have dimension table and fact table. So this is dimension, and this is fact table. Okay, this is data warehouse. Okay, and then in between ODS and data warehouse, we will have another database called staging area. This is called staging area or stage database. If you see, staging area and stage database also replication of ODS database. So whatever data present in ODS table, the same tables also present in staging database. So first here there will be some ETL mappings to extract the data from ODS T1 table, transform and load into the stage T1 table. In the same way, there will be another ETL mappings to extract the data from ODS T2 table, transform and load into the stage T2 table. So here also there will be some ETL mapping to load the data from T3 table, extract the data from T3 table, transform and load into the stage T3 table. In the same way, T4 to T4. Like that, the data will flow from ODS to staging database. And then once the data is available here in the staging database, again ETL will happen to extract the data from stage, transform and load into the data warehouse. So like that, the data will flow to the data warehouse. Okay.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
So here from ODS to data warehouse, we should not load the data directly. Okay, for example, let's say there is a table in ODS, right? T1 table. So this is a ODS T1 table, right? So here we have some columns like this: employee number, employee name, salary, create date, update date. So like this, we have one ODS table. Okay, so here we have some records like this: create data, run date. So let's say we have employee number 10, A100, some create date. Create date, let's take today's date. So today is 8/24, okay, 2021. Okay, same run date also will have today's date. Next, second record 20B 200, and here we have this one 30C 300, and here we have like this. Fourth record 40T 400, and here we have like this 50E 500. So like that, there are 5 rows in ODS T1 table. So for one of the row, let's say create date, by mistake someone has inserted like this. So through some other application, or let's say we have got like this. Okay, instead of create date, so we will take salary. So let's stay here salary. For one of the record, we have the null value in ODS T1 table. We have the salary as null value for one of the record. Okay. Now here in this case, if you create here, if there is a ETL which will extract the data from ODS, transform and load into the data warehouse, that ETL, what it will do, it will extract these 5 records and it will insert all the 5 records into the data warehouse, right? So data warehouse, there we will not have the constraints. So constraint means primary key, foreign key, check constraint, default, not null constraint. So these constraints we will not set in the data warehouse, because if you have the constraints on the data warehouse, so the load will happen, I mean, like it will take long time to execute, because queries also will take long time, and the insert also will take a long time if there are millions of records. So generally we will not have any constraints. We know we have to store historical data in data warehouse. Whatever the records coming from the source, all the records should insert inside the data warehouse. Okay, so that is the reason here we will not have any constraints. Whatever data coming from the source, same as it is, we will insert into the data warehouse. Okay, so now in data warehouse, if you insert all these 5 records, there for one of the row we have salary as null, so which is incorrect record. So there should not be salary as null. So someone by mistake, they have inserted the salary as null for one of the employee in the source table. Okay, so if the ETL process will extract these 5 records, and if it is going to insert all the 5 records into the data warehouse will have the incorrect data. On top of the data warehouse, if the reports are going to be generated, incorrect or invalid reports are going to be generated. So that is the reason, before loading the data into the data warehouse, first here in the stage database or staging area, so there will have all the constraints in stage tables. Okay, so inside the stage table we'll have all the constraints. Date should be 1 to 31, month should be 1 to 12. Okay, salary should not be null. Okay, employee number should not be duplicate. So primary key, like that, all the constraints at a database or table level we will have in the staging database. In staging also, now let's say we have the table. So stage T1 table we have. So if you have the stage T1 table like this, so in ODS we can have the validation, but sometimes it may happen to get incorrect data or duplicate data, even though you have the validation here. So I will tell you another example. There, even though you have the validation, sometime you may get incorrect data. So what type of incorrect data will get even though if there is a validation, that we will see. So first here in staging table, let's say stage T1 table you have here: employee number, employee name, salary, create date, and then run date, something like this we have. So these are the columns we have. Now in on stage T1 table, we have not null constraint. Okay, let's say here in ODS, let's say they have not created the not null constraint. So because of that, here it allowed to insert the null value. Okay, somehow there is no constraint on salary column. So that's the reason here it allowed to insert the null value. Otherwise, if there is a not null constraint here itself, okay, so here we will not get the null value. So I'm just giving the example of error record. How, like, what is the purpose of staging area here? Okay, and why can't we load the data directly from the ODS to data warehouse? That I'm explaining currently. Okay, so now if you have not null constraint, in this case, what will happen? So if the ETL process happens to extract the data from ODS T1 table, transform and load into the stage table. Okay, so since we have the not null constraint, what will happen to that ETL process? So it will fail the execution. It will not be allowed to insert these records. Now, let's say it has failed the execution. So after failing the execution, then ETL team, they will check why there is a failure. Because of the incorrect record there is a failure. Then we will check in ODS. So ODS source side, here again there will be some other team, technical team will be there. They will be maintaining the data between these two databases, mainly OLTP and ODS. There will be some other technical team, they will be maintaining the data between these two databases to maintain in a sync. Okay, so once we have the data in ODS, so ETL team will extract, transform, and load into the staging and stage to data warehouse. So now while loading the data here, it has failed because of the null value. So here ETL team, they will inform to the ODS team or source team saying that, so for one of the record, there is an incorrect value. So you have to fix it. Okay, so after fixing again, so suppose let's say ODS team, they have updated some salary here. So again, if the ETL process runs, that this time we will have all the valid data. That valid data, it will ETL process will extract, transform, and load into the staging database. And from stage again, it will extract, transform, and load into the data warehouse. Now this time, data warehouse will have all the valid data. Okay, so we'll talk about another scenario. So in another case, we have some salary here. Okay, and by mistake someone has inserted, so here create date something like this, 8/24/2055. Okay, create date 8/24/2055. Okay, since we have the future date here, now in this ODS T1 table, we have the validation. Let's say we have set on employee number, there is a primary key, salary, we have not null constraint. So date also we are, checking like whether it is a 1 to 31 or month is 1 to 12, like that it will allow. But we do not have validation at a table level, whether it is a future date or less than or equal to system date. So like that, such type of validation we do not have, right? So to check whether the date is less than or equal to system date or the future date. So that is the reason for the year we do not have any validation. So it allowed someone by mistake, they have inserted the future date record here. So it is not possible to have the future date record. So in this case, what will happen? So this record future, all the 5 records, if you execute, like if the ETL process is executed, so from ODS to stage, it will extract all these 5 records and it will insert all the 5 records into the stage T1 table. Again, so from stage to data warehouse, again, these 5 records will be extracted and it will be loaded into the data warehouse, right? So in data warehouse also, let's say we have these 5 records. We know on top of the data warehouse reports will be generated. Let's say here we have, there is a separate team, reporting team will there. So that team, they will extract the data from the data warehouse and they will generate a report. So in that report, they have written a logic to extract the records from data warehouse where created less than or equal to system date. So like that, they have written the logic to extract the data from data warehouse where created less than or equal to system date. So in this case, it shows only 4 employees information, right? So here we will get only 4 employees information because for one of the record there is a created future date. So we have all the validations, but still, so this incorrect record is present in ODS, stage, and the data warehouse. Okay. Now what business people will do? Business people, as soon as they receive the report, so they are going to do the analysis on their report. So during their analysis, they found that only 4 employees information. They are expecting 5 employees information, but here we have only 4 employees information. Now what business people will do? They will raise a ticket or an incident. So to the reporting team first. So then what reporting team will do? they will do the analysis. During their analysis, they found that in a data warehouse table, there is an incorrect record. Future date record is there. So because of that reason, here in the report, it has extracted only 4 employees information. Now that ticket will move to the data warehouse team. So data warehouse team, they only loaded the data from stage to data warehouse, right? So as soon as that ticket data warehouse team receives, what data warehouse team will do, they will write a query and see whether that incorrect record is present in the data warehouse or not. So after executing the query, so they found that that incorrect record present in data warehouse. Yes, for one of the record there is a future date. Now again, from where that incorrect record has loaded, from staging. So like that, now they are going to do the backtrack. Now first, client side technical team will be there, or source team or ODS team. So they should have to fix that record first in ODS database. Okay, suppose let's say if you are working in the team, so you have to write a update statement or through front end application to, you have to fix that record. Okay, so here you will be let's say so they have done the analysis, and so they have sent to MS SQL or database team or DBA team. So they have sent that request. Whoever is responsible to correct the data in the database, they should have to take the responsibility and they have to fix that record. So first they have to fix that record by writing the update statement. Let's say ODS team or client, they have confirmed that this should not be 255, it should be 251. So like that they have confirmed. So if they have confirmed to correct this date, instead of 2055, it should be 2021. So if you have got the request, you have to write an update statement to correct that record in ODS database. So update create date is equals to 8/24/2021, where employee number is equals to 50. So like that, we have to correct that record. That is called data fixing. In the same way, we also have to execute the update statement in staging database. In stage T1 table also, there also that update statement should execute, right? So like that, we have to correct the data. So to correct the data, we have tried an update statement. So this time here in this scenario, we have only one incorrect record. Okay. So in real time, there may be chance to have, many records also incorrect. Sometimes we may get 10 records or 100 records or 1000 records or 1 million records also we will get such type of incorrect records because of, sometimes because of suddenly the services failure or server went down. So by mistake, something if happens, there may be chance to get the incorrect records or duplicate records or error records like this in the source database. When the data is flowing to the data warehouse, so there may be chance to load such type of incorrect records across all these databases. So here during the analysis, sometimes, instead of now this time here, client has found that the one employee record is missing in the report. Sometimes here data analysis team also will be there. So if you are in data analysis team, so you will be writing the queries to find the incorrect records in those database tables. Okay, so they will be giving the some business criterias. Okay, so if this doesn't satisfy, then consider that as an error record, or check are there any duplicate records, or check are there any future date records, or check are there any null values in this column. So like that, you will also be writing the queries and doing the analysis, and finding for the error records or incorrect records. So after finding the error records, then we should have to get the confirmation with the client. Okay, so these are the records we have found as incorrect record. So in these rows, we have the invalid information. Please let us know what data we have to update here. So once you get the confirmation from the client, then you have to write an insert statement or update statement or a delete statement, depends on our requirement. So how we want to fix. So if there are duplicate records, right? So like that, we'll be fixing those records here in ODS stage and data warehouse. Once the data loaded into the data warehouse, on top of the data warehouse, reports will be generated and those reports will send it to the business people. So like that, the data will flow from one database to another database, right? Next. So this is standard data flow, like the different databases will be there. Okay, and then inside those will have the tables. So while loading the data, if there are any incorrect records, so we should also have to fix those incorrect records and load only valid data into the data warehouse. So in some of the companies, again, instead of directly generating the reports on top of the data warehouse, here next to the data warehouse, we will have data mart. So inside MS SQL also we can create data marts, right? So what is data mart? Data mart again inside the MS SQL is a software type. That's a type of database software, right? Different databases we can create. Inside the databases we'll have the schemas. Inside the schemas we'll have the tables, right? So like that MS SQL itself we can have this data warehouse, ODS, stage. Okay, all these databases we can have, and also in the same way we'll also have the data mart. So what is this data mart? So why we have this data mart means, so we know data warehouse contains the historical data, years of transaction data will be there. Let's say here we have 10 years of transaction data. So if they are extracting the report on top of 10 years of data, definitely queries will take time to execute. So they don't want to display all the 10 years of data in the report. They just want to display last 3 years of data. So if they want to display only last 3 years of data in the report, and so if that 3 years of report query is going to execute on top of 10 years of data, then definitely queries again will take a long time to extract that report information, last 3 years of report information. So that is the reason, here we'll have the data marts. Data mart also, this also contains the historical data, but this historical data is specific to the report. Okay, so now business people, let's say they want only 3 years of data in that report. Okay, so what here data mart here in the table, we will maintain only 3 years of data. Okay, so again, ATL process will happen here also to extract the data from the data warehouse, last 3 years of data, transform and load into the data marts. So here, instead of selecting all the 10 years of data, so whichever the data is required to generate a report, only that data will be loaded into the data marts. Suppose now, let's say business people says that I want only last 6 months data for my report, or last 1 year data. So then in that table from data warehouse, you select the recent last 1 year data or last 2 years data and maintain only that last 1 or 2 years of data into the data marts. Okay, so on top of the data marts, if the report is going to be extracted, then it will not take much time. So very quickly the reports are going to be generated, right? Compare with the data warehouse. On top of the data marts, if the reports are going to be generated, it will be very easily accessible. Okay, so this is the data flow inside the any type of database software will have these databases. Again, data will flow like this. So finally it will be loading into the data warehouse. We know data warehouse contains the historical data. As I told you, on top of the historical, like historical means from last 10 years or 20 years. Okay, so we'll have years of transaction data in the data warehouse. If you execute small query also, it will take a long time to execute or to return the result. So that is the reason instead of extracting all the reports on top of the data warehouse, so instead of extracting all the data, all the reports on top of the data warehouse, so as I told you, so the from data warehouse again in data marts will have different tables. So each and every table, so if the report is going to be extracted on top of that table, so that report, if you want only 3 years of data, also from data warehouse, we in that data mart table will maintain only 3 years of data. Okay, so let's say in this data warehouse, we will store the data at enterprise level. So enterprise level means, let's say in a company, if there are 10 departments are there. Okay. So data warehouse will store all the 10 departments data. But while generating the report, so for each and every department, we need to have the separate report. Okay. For department one, we need to have the separate report. For department two, we need to have the separate report. For another report, we need to have another data. For another department, we need to have the separate report. So for that, instead of maintaining all the 10 departments data in a single database, which is the data warehouse, so again from data warehouse we can connect to each data mart like this. So again ETL process will happen. So the data will warehouse to different data marts. If there are 10 departments, we can have 10 data marts, and on each and every data mart corresponding to that department report will be generated. Okay, so we can create the ETL process. So whatever the process here will load the data, extract, transform and load. ETL process will take in care to maintain the data between these databases. We can also call it as a data transformation, or we call it as a ETL. So there are different ETL tools in the market like Informatica, Power Center, Data Stage, Ab Initio, Pentaho, okay, Warehouse Builder in SQL. I mean, like we can also have the PLSQL packages to transform the data from one database to another database. But finally, so very rare will be generating directly on top of the data warehouse. So again, from the data warehouse, data will be transferred into the data marts. So all these types of like OLTP, ODS will have, will be there in MS SQL. So these are the naming conventions of again the databases which will be creating inside that MS SQL. Only the data warehouse will have the dimension and fact table. So all the other like OLTP, ODS, staging, and data marts, or sometimes in data marts we also called it as reporting database. So this is also we call it as a, in some of the companies they will call this as a data mart, or in some companies also called it as a reporting database, or some companies also called it as a materialized views. So materialized views also will be created, because in data warehouse, let's say there is a table. In that table, if there are 100 columns, okay, and there are 1 million records in the table, but for the report they don't want all the 100 columns, they just want only some 40 columns of the data in the report. Okay, and also they don't want all the 1 million records. So in that table, let's say there are active and inactive records are there. So they want to extract only active records, and 40 columns of data they need. So in that case, if the materialized view is created on top of the data warehouse table, okay, to have only 40 columns and only active records from that table, the materialized view physically it will be created in a database, and that view contains only active records and with 40 columns of data, and on top of that as a source, so materialized view as a source to generate a report. So like that in some of the companies, they will be creating the materialized views also after a data warehouse. In some companies data marts will be created. In some of the companies also called it as a reporting database. So all these things will be there in a same, MS SQL or Oracle or Sybase DB2 Teradata, depends on company. So they will be creating such type of databases and all. Okay, so we should have to be aware of these things, the data flow and what type of databases will be there. So now we'll talk about what is dimension and what is fact table. Dimension table, or we call it as a dim table or fact table. So dimension table contains primary key and master data. So if there is a table which we are calling as a dimension table, we can say that it contains the primary key and master data. Okay, so master data also we called it as a non-measurable data. Okay, so whereas fact contains primary keys of the dimensions, okay, or we also called it as a foreign keys, and measurable data or measurable columns or data will have. Okay, so this is the definition of dimension table and fact table. So while loading the data from relational table to a dimension and fact table, so all the master data, which is non-measurable data, will load into a dimension table, and measurable columns or measurable data will have in a fact table. So I have one dimension and fact model here in the data warehouse. We will have the schemas like star schema and snowflake schema. Okay, so we have these two types of schemas in data warehouse. Okay, so in star schema, I mean, like here you can see we have a dimension table and fact table. Okay, so dimension table, here we have item dimension, branch dimension, and then time dimension, location dimension. Like that we have different types of dimensions in data warehouse. Okay, so if you see in this dimension table, we have a primary key. Item key is a primary key column, right? So apart from the primary key column, the other columns are item name, brand name, sold by, category. All these are non-measurable columns. In the same way, here we have branch dimension. So branch dimension also, here we have branch ID, which is one primary key column. The other column, branch name, owner name. Branch and owner name are non-measurable columns. In the same way here, time ID, it's a key column. The other day, month, quarter, year are non-measurable columns. Okay, so location, here we have location ID, name, state, pin code. So here also location ID is a key column. The other columns are non-measurable columns. In dimensions, you will not find the measurable columns. That's how it is designed. So generally, this and all architect level architects, they will design the data models and they will decide which column should be there in a dimension and which column should be there in a fact. Okay, but we just have to know what is dimension and what type of data will be there in a dimension table and what type of data will be there in a fact table. Now if you see fact, so here we have foreign keys. Foreign keys means like primary keys of the dimensions. Item key, which is in a dimension table, also present in a fact table. Branch ID, here we have in a dimension table, same present in a fact table. In the same way, time ID also present in a whatever is present we have in a time dimension, the same time ID and a branch ID from the branch dimension, location ID from the location dimension. Like this, fact table contains primary keys of the dimensions or foreign keys like this, and also other columns are measurable columns. Quantity sold, so quantity is a number type of data, so which is a measurable column. Amount sold, amount again it's a number type of data. Average sales, it's a number type of data, right? So all these columns are measurable columns. Like this, dimension contains the key column. Apart from the key column, the other columns are non-measurable columns. Fact table contains primary keys of the dimensions, which are foreign keys, and the other columns are measurable columns. Okay, so like that we will have the schema. So inside the schema, or we call it as a data model. So in a data model or a schema in data warehouse, we'll have dimensions and facts. Dimension contains the primary key and non-measurable columns, whereas fact contains primary keys of the dimensions and the measurable columns. This is how the dimension and fact will be differentiated. And as I told you, it's architect responsibility to design the data model like this. Based on this, they will be creating, DBS will be creating the tables and all. So if you store the data like this, it would be easy to generate a report. So for easy access report, so this dimension fact models are designed and compare with the relational. So here, if it is designed based on the data warehouse model, reports would be easy to access. So that is the reason this dimension fact model we have here. Next. So we have two types of schemas in data warehouse. The first one is star schema. The second one is snowflake. So what is star schema model in data warehouse? Means, so you can see this is a star schema model. Why we call this as a star schema model? Means in a schema or a data model, if fact is connected with all the dimensions, then we can call this as a star schema model. Connected means all the dimension keys should present in the fact. Now here there are 4 dimensions. So that is the reason we call this as a star schema model. If at least one of the dimensions, suppose let's say this branch ID is not present in this fact table, then we cannot call this as a star schema model. Okay, so in star schema, all the dimension keys should present in the fact. Then only we can call that as a star schema model. We have another schema here, which is called snowflake. Okay, so in this snowflake schema model, we have one fact, and left side to the fact we have 4 dimension tables. Right side to this fact we have total 5 dimension tables. So in this schema, we have total 9 dimensions are there. Even though we have 9 dimensions, we have only 3 keys present, like date ID, store ID, product ID. So like that, we have only 3 dimension keys are present in this fact table. So like this, in a schema or a data model, if only few of the dimension keys are present in the fact, not all the dimension keys, only few of the dimension keys are present in the fact, then this model we called it as a snowflake schema model. Okay, or so at least one of the dimension key is not present. Let's say you have total 9 here, you have 8 dimension keys in this fact, but the one dimension key is not present. That means one dimension is not connected to that fact. Okay, so in that case also we can call this as a snowflake schema model. So fact table contains few of the dimension keys and measurable columns in snowflake schema model. Whereas star schema model, fact should have all the dimension keys. Again, so it's under all architect level, they will design the data model schemas like this, and they will decide which column should be there in a dimension and which column should be there in a fact. So we just have to know what is star schema model and what is snowflake schema model. So in data warehouse, we have different types of dimensions. We have four types of dimensions here. One is conform dimension or reusable. Okay, the fourth one is slowly changing dimension or SCD. So in slowly changing dimension, again, we have three types. Okay, so SCD type 1, SCD type 2, SCD type 3. So SCD type 1 dimension contains the latest data or current data. Whereas SCD type 2 dimension contains, historical data. So whereas SCD type 3 dimension contains partial history. Okay. So conform or reusable dimension means if any dimension can be reused across multiple projects. Same dimension table. So if you use across multiple projects, then that is called conform dimension. For example, let's say there is a employee dimension. So employee dimension is there. Here we have employee number, employee name, salary, something like this we have. So you are working for, let's say, project called GE. So you are working for a GE project. So in this GE project, there is a employee dimension. So this employee dimension contain, GE employees information. So let's say he is a GE employee. Okay. So in the same company, there is another project called AE, Aero Electronics. Like that, you have another, project in the same company. Okay. So here also we have to create an employee dimension. So here there is an employee table created. Okay, now here also we have to create an employee table. So can we reuse whatever the employee dimension we have created? No, right? It's not possible. We cannot do like that because this employee dimension contains GE employees information. We cannot reuse this dimension into another accounts or another projects. Okay, so this is not valid. So this is not a conformed dimension. Okay, so instead of employee dimension, let's say we have another dimension in this GE called calendar. So in this calendar dimension, we have all the calendar information. Okay, so the date and time, and the calendar dimension generally it contains the holidays. Okay, so public holidays and all. So those things will be there in the calendar dimension. So we are sure that calendar data remains same across multiple projects. So that calendar information is not going to change. Okay, so conform dimension contains, the data which can be reused across multiple projects. The same data, again, we should not change anything. Such type of dimensions, we can call it as a conform dimension. We just have to know the definitions. And then junk dimension. So junk dimension means if any dimension data every second or every minute, if it is getting keep on updated, the latest data if you are getting, for example, let's say stock market information, if you store in any dimension, so that data every second or every minute we will be getting the latest updates, right? So such type of information if you store in any dimension, then that dimension we call it as a junk dimension. Then degenerated dimension. So degenerated dimension means now, here we have a pin code. Let's say in a location dimension, here we have a pin code. So pin code contains characters. Sometimes we'll have numbers also, right? So let's say that one we have stored in a dimension. Pin code column currently we have in a dimension. Okay, very rare. We will also store such type of columns in fact also, which is a non-measurable pin code. Pin codes we cannot measure, right? But that will have the number type of data also. Okay, so such type of columns if you store in a fact. Okay, so if any dimension is sharing its non-measurable column with a fact, then such dimension we call it as a degenerated dimension. Here, for example, location dimension we have. In location dimension, we have a pin code column. So that pin code column we have in a location dimension as well as in factor table. So that pin code column is coming from, location dimension. So in this case, so whichever the dimension is sharing its non-measurable column with the fact, then such type of dimension we call it as a degenerated dimension. Next, slowly changing dimension. In slowly changing dimension, we have three types: SCD type 1, SCD type 2, SCD type 3. So type 1 data means, let's say in a source table, you have a table like this, EMP underscore SCD type 1 underscore source. Here you have employee number, employee name, address. Okay, and here you have 10 A HYD, 20 B BLR, 30 C CNI. Like this, we have a source table. And then, so let's say here we have a target table. This is target. Now, while loading the data from source to target table, how the data will be maintained in this table for SCD type 1 means, okay, along with this, we also have the create date, update date. Okay, so how we will maintain the data means, for the first time, we will check whether the source record present or not in the target table. If the source record does not exist, so it should be insert, right? Okay, so here we will be inserting like this. 10 A HYD create date should be a system date. So it should be 8/24/2021, and update date also will have system date. Okay, and then for the second record also, source record does not exist. So second record also is going to be insert like this. Third record also does not exist. This record also going to be insert like this. So for the first time, none of the records present in the target table. So all the records is going to be inserted. This is how data transformation will happen in SRE type 1. Okay, second time, let's say this employee has moved HYD to USA. So here we have got an update as USA. So let's say we have got this update on 8/25. On August 25th, he has moved to USA. So if you have got an update here to move to USA, so this time if we execute this mapping, let's say we are executing this mapping on next day. Tomorrow we are executing this data transformation. So what will happen? It will check whether the source employee number exists or not in the target table. Okay. So now in this case, what will happen? So we have to update here. Only specific columns we have to update, right? So we have, if the source employee number already present in the target table, we should have to update the record in the target table. So HYD with USA, and also we also have to update the update date. So like that it will happen in type 1. So this is going to be 8/25/2021. So we are not going to update the employee name and also create date. Create date is the date which actually the record got created. Okay, so we no need to do anything for the second and third record because there is no change. Okay, so no insert, no update. We just have to leave that record as it is. Okay, next third time. Third time again, let's say this employee has moved US to UK on August 30th. Okay, let's say on August 30th, we have got an update here in this table. So this time in SRE type 1, what we have to do, again, if we are running this transformation, data transformation between source to target on 8/30th, it will check whether the source employee number present or not. So this source employee number does not, it's already present, and there is a change between source and target record. So in this case, again, it should have to update USA with UK. So here we have to update with UK. And then update date also, it should be updated to 8/25 to 8/30. Like this, it should be updated. Okay, so for the second and third record, no change. So if we got the new record here in the source table, that new record should be inserted inside the target table. So like that, it should happen. So employee number 10, he was there in HYD, and then he moved to USA and currently is in UK. So we have whatever data present in the source, same as it is we have present in the target table. We don't have older transactions here, right? So whatever data present in the source, same as it is if you maintain in the target table, that is called, latest data. It will not update automatically. So there will be some ETL process. Okay, so ETL jobs will be there, Informatica team or ETL team. So or PLSQL team, project depends on the client. They will decide how they want to process the data. Okay, so it will not be updated automatically. So there will be some process to transform the data from source to target, right? So that process will take care to maintain the data like this in the target table. Okay, so as soon as that process is executed, that will take the source employee number and it will check in the target table whether it is present or not. So if it is not present, then it will insert. If it is already present, then it will check, is there any change between source and target? If there is a change, then it will update only the specific columns in the target. Okay, so like that it will happen. So this is in SCD type 1. Next, SCD type 2. How it will happen in SCD type 2? So employee number, employee name, address. So here for the first time we have like this in the source table. So now let's say here this is the source and this is type 2 target. So here we will have another key column should be there, employee ID. On top of this we'll have the primary key constraint, and then here we'll have effective start date and effective end date also will be there. Okay, so here also what we have to do for the first time, we should have to check whether the source employee number present or not in the target. So here we have to insert the record. While inserting in this EID primary key column, so identity should be defined on this EID column, or we have to generate a auto increment sequence number. So we have to set on top of this column. So that will take care to generate a sequence value 1, 10, 10, A, HYD will come from the source. Effective start date, it should be a system date. 8/24/2021. End date, always it should be 1/1/9999 future date. Okay, so like this. So start date column, here we should have to load the system date, and here it should be always future date in type 2. Next, for the second record, so employee number 20 also does not exist. This also we have to insert 2, 20, B, BLR, and this one. So like that we have to insert. For employee number 30 also does not exist. 3, 30, C, CNI, and this one. Like this, for the first time, none of the record present in the target table. So all the records that ETL process, will extract, transform, and load into the target. So this is a data warehouse table. SCD type 2 target is the data warehouse table. So here we are seeing like how the data will be maintained, the historical data. Second time, let's say this employee has moved H1 to USA on August 25th. Okay, so this record we have got on August 25th. So tomorrow, if we are executing this mapping to load the data from source to target, so what will happen? It will take the source employee number, check in the target whether that is present or not. So this time already present. So if it is already present, is there any change between source and target? Yes, there is a change. Source we have latest address USA, whereas in target table we have previous or old address. Instead of updating the address, what we have to do is, so we have to update the end date with the system date to make that record as inactive. Okay, so here we should have to update the end date with the system date first. That ETL process will take care all of these things. We just have to know the concept, how it is going to maintain the history. So it will be updating with the system date. This date is 8/25. Let's say since we are executing this mapping on next day, so it will be updated with the system date. And then the latest updated record for the same employee, a new record will be created. This is a sequence value here. It will be generated. Employee number 10, A, USA, and 8/25. And this is 119999. So like that we should have to insert. Okay, next let's say again this employee has moved USA to UK. Okay, so we have got an update here, UK. So this, he has moved to UK on August 30th. So we have got an update on August 30th. This time what we have to do, so we should have to check in the source and target. So do we have source employee number present or not? This time for employee number 10, how many rows are present in the target? There are 2 rows. In these 2 rows, to make the record as inactive, so we have to update the 4th record, which is the active record. This is, we call it the active record. The first row is inactive record for that employee. So active record end date should be updated with the system date. So this one, it should have to update.
Just a quick info, guys. Intellipaat provides Business Intelligence Masters program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
With system date, sys date is 8:30. So if you are running this load on 8:30, so it is going to be 8:30, and then the new record is going to be inserted for the same employee. 5, 10, A, UK, 8:30, and then here 119999, like this it is going to be inserted. Whenever we insert, this should be a system date and it should be a future date. Okay, next second and third record, there is no change, no insert, no update. So again, fourth time, if any new record comes here, this employee number 40 record needs to be inserted. So fourth time, if this load happens, so the data is going to have like this in the table. So you can see 440 DEL, only this record, not 4, the here 6 sequence number, for the next row 6, and here the state, let's say if it is 8:30, so it is going to be inserted like this. This is how the historical data will be maintained in the data warehouse. So next we have SCD type 3 partial history. So we'll see how to maintain the partial history here. EMP SCD 3 underscore yes source table. Here we'll have employee number, employee name, original address, and current address. Let's say here we have address in 2 different columns. Okay, so we have address in 2 different columns, and then currently we have 1A HYD, current address also HYD. For the first time we have the same. Or what we will do is, here we'll have only one column for the address. Target will take 2 columns. So like that, here we have the source 10A HYD, 20 BBLR, 30 CCNL. Like this, we have a source table. So whereas in target table for type 3, we'll have like this. So here, original address and current address. Okay, so original address and current address, and if you want, you can also have create date, update date columns. Okay, so now for the first time, none of the record present in the target table, all the 3 records needs to be inserted. 10A, original address also HYD, current address also HYD, and also we'll have the create date, update date columns. So create date today's 8/24, update date also will have today's date only 8/24. Next, for the second record, 20 BBLR, and this is BLR, and this is 8/24, 8/24. Okay, next 30 is CNI, and this is also CNI, and 8/24, 8/24. So like that, for the first time, none of the records will present, on all the records are going to be inserted inside the target table in SCD type 3. So next time, let's say if you have got an update here. Okay, so here this employee has moved HY to USA. So we have got an update here. So this update we have got on August 25th. Okay, so this employee moved to USA on 25th. So this time, let's say we are executing data transformation happening on 25th. So in that case, this date will be 25th. So it will take the source employee number, check in the target table whether it is present or not. Since it is present, now what it should have to do, it will check whether is there any change between source and current address. So here we should have to compare between original source address and the current address. These 2 columns we should have to compare. So if there is a change, yes, then what we have to do, we have to update the current address and the update date. These 2 columns we have to update here. Original address remains same. So current address only we will be updating to USA, and then here the update date will be like system date 8/25. For the second and third record, there will not be any change, no insert, no update. So it will just leave that as it is. Okay, next again, let's say again we have got an update. This employee again, he has moved USA to UK. So in the source table, we have got an update here. So let's say here we have got an UK, and this update we have got on August 30th. We have to compare. So we'll check whether the source employee number exists or not. If it is already present, check is there any change between source and target. While comparing, we have to compare with the current address. In source we have UK, whereas in target we have USA. Now in this case, what we have to do, we have to take the source address and update that source address in the target table here in the current address column, right? So we'll be updating UK, and also we'll be updating the update date. So update date with the system date. Sys date is 8/25. So like that it will be 830. So it will be updated. Okay. So for second and third record, there is no change, right? So like that it will be updated. Now in this case, you can see here. So he was there in HYD from basically from HYD, and then he moved to USA. Okay, and then he moved to UK. We don't have in between transaction. We have original transaction, and also we have the latest transaction. In between transaction data we don't have. USA record we don't have. So original transaction we have, and also we have the current transaction. This is called SCD type 3. Okay, and if you have any other columns here, suppose let's say contract number. So you're saying contract number. So contract number, some numbers you'll have like this, something like this. If you have here also we'll have only one column. So basically here in SCD type 3, we should have to decide on based on which column we have to maintain the partial history. So here we are maintaining the partial history based on the address column. So based on address only we are deciding if there is a change between source and target. Okay, so type 1 and type 3 difference, if you see here in type 1, finally we have got an update as UK, right? The same UK present. But here he was there in HYD, he was there in USA. The original transaction also we have here. Whereas here in type 1, we do not have original transaction. We have only recent transaction here. That is the difference between type 1 and type 3. So type 1 will have only a recent transaction, whereas in type 3, we'll have both like original and current transaction. In between transaction we do not have. So these are the three types of mainly the slowly changing dimensions we have in data warehouse. Next, we'll have types of facts. Facts also we have four types of facts. One is additive fact, the second one is semi-additive fact, third one is non-additive fact, and fourth one is factless fact. So additive fact contains primary keys of the dimensions, or we also call it as a foreign keys, and measurable data. Whereas this one contains a semi-additive fact, few of the dimension primary keys and measurable columns, measurable data. And non-additive fact contains no primary keys of dimensions, and it contains only measurable data. So factless fact, it contains only primary keys of dimensions and no measurable data. So the fact which we have in a star schema model, this fact we called it as a additive fact because it should have primary keys of the dimensions and measurable data. All the primary keys of the dimension should be there inside this fact. Okay, whereas semi-additive fact contains only few of the dimensions. So the fact which we have in a snowflake schema is called semi-additive fact. So semi-additive fact contains only few of the dimension keys and measurable data, not all the dimensions. Okay, and then non-additive fact, no primary keys of the dimensions and only measurable data, which means that fact will not have any of the dimension keys. So that will not be connected with any of the dimensions, which contains only measurable columns. There will not be any dimension keys. So if any fact contains only measurable data, no primary keys of the dimensions, then we can call that as a non-additive fact. Okay, and then factless fact. So factless fact, we have only primary keys of the dimensions and no measurable data. So it should have all the dimension keys, but these columns should not be there. No measurable data. Such type of fact, we called it as factless fact. So non-additive fact. So in data warehouse schema, so any table which contains only measurable data and no primary keys of the dimensions or no foreign keys, nothing, then that is called non-additive fact. So that will be there in a data warehouse. That's why we call that as a fact. Next, so generally data mart contains a specific department history, whereas data warehouse contains enterprise level history. So enterprise level means all the departments historical data. If you store in any data warehouse, like if you store all the departments historical data, then that is called data warehouse. So if you store any specific department history or a report based history if you store in any database, then that is called data marts. So we can have n number of data marts, but data warehouse can be only one. So where we'll have all the departments historical data, which will be for enterprise level history will be there in data warehouse. Whereas in data marts, we'll have only specific department level history. Okay. So we have finally in data warehouse, we have a top down and bottom top approach is there. So top down approach means, so from OLTP to, this is OLTP, this is ODS, this is staging, and then this is data warehouse. Okay, so from data warehouse, if you load the data into the different data marts, this is called top down approach. Okay, so this is OLTP database, and this is ODS database, and this is a staging database, and this is a data warehouse database, and these are the data marts. Data mart 1, data mart 2, data mart 3. Okay, so this is called top down approach. So on top of the data marts reports, if they are going to generate a report in data warehouse, we call this approach as a top down approach. Whereas bottom top approach means, so instead of loading the data first into the data warehouse, so first we load into the data marts. From staging, we can also load the data into the data marts, and then from data mart, again, instead of generating the report on top of the data marts, so we can load the data into the data warehouse, and then the reports will be generated. This is very rare. Most of the times top down approach only will be there. So here this is a data warehouse. So from data marts, again, if you load the data into the data warehouse, on top of the data warehouse, if the reports are going to be generated, then this is called bottom top approach. Okay, but generally we'll have top down approach. So these are the concepts we have in data warehouse.
Data mart is nothing but a subset of our data warehouse. So consider this is my the transactional database which we are having, okay, in real time. So this is operational systems. So we are not going to load in a single stage to the data warehouse. We do have so many stages will be available. Okay, so from the OLTP to OLAP transfer, right? Data transfer. So definitely we do have multiple stages available in the real time. So like staging area is one of the stages in the ETL process. Like we will land all the data from different OL system to OLTP system to staging. From the staging to, we will move the data to data warehouse. So from the data warehouse, a subset of data warehouse we will create either logically or separate data mart will be created. Again, the data mart also a database only, but it is a logically divided. So how we do have 1 TB of hard disk have been divided like C drive, D drive, and E drive the same way. So here also we will logically divide the data warehouse or one particular database into multiple data mart. The data mart will have a subject oriented informations based on their business. So consider this is the this is the difference between data warehouse and data mart. The data warehouse, it will have all the enterprise data. Okay, so it will have all the enterprise data, but data mart will have a particular subject, a department by data. So here we do have multiple subject areas are available in this particular data warehouse, but here it will be a single subject area. Each data mart will have single subject area. So multiple data sources, definitely it will have multiple. From the multiple data sources, we will accumulate all the data. We will integrate the data into warehouse, but here it will be limited data source. So might be the source for data mart. Again, we need to do the ETL process to fetch the data from data warehouse to data mart. Here we used to do one ETL process. Again, here ETL tool will be introduced. So here it will occupy large memory. Okay, the data warehouse will occupy large memory, but the data mart will occupy limited memory. So this will take lot of time to implement this data warehouse, but the data mart will take some shorter time to implement it. So this is the major difference between data mart and data warehouse. So we do have different types of data mart in the real time. So for example, 3 different types of data marts are available. So the first types of data mart is independent data mart. Okay, so the dependent data mart and independent data mart and hybrid data mart. So what is meant by independent data mart? So here we do have OLTP systems. So from the OLTP we are moving the data to data warehouse. So from the warehouse we are fetching the data for our data mart. So this is called dependent data mart. The data mart is dependent on the data warehouse. Okay, so from the warehouse we are pulling the data. So the data is first extracted from the OLTP system and then populated to the data mart, the central data warehouse to data mart. So from the warehouse the data travels to the data mart. But here independent data mart, here the data warehouse will not be available. Okay, so directly the data mart will be loaded from OLTP source. So this is called independent data mart. And then we do have hybrid data mart. So the hybrid data mart, the data mart will get the data from either from the OLTP system or from the data warehouse system. So this is the 3 different data mart available in the data warehouse. So what is the data modeling? So data modeling is nothing but, so for example, if the business users so will give us the business related terms, okay, business related terminologies. He knows or she knows the business and she wants to convert the business into a model, okay, data model. So how to convert that? So we do have a different methodology to draw this, okay, to create that data model. So we do have 3 different method. So one is called conceptual model and logical model and physical data model. So what it does mean? So what is conceptual model? So how to create this conceptual model, and what is logical model? What is physical model? We will see one by one. You assume that, so we are going to create the data model for one of the particular uh, uh, particular online portal or something. Okay, so online uh, portal, the online product selling portal we are going to create it. This online portal, right? Definitely they do have they need to have. So these are all the tables we should have. So in order to have our customers informations, we need to have the customer table. In order to maintain our employees details, we will have the employees tables. In order to maintain the customers accounts, we will have the accounts table. In order to maintain the product information, we'll have the product, we have the region table. So to have the different regions on the sales, to analyze which region is performing well, to analyze which product is performing well, so which account they have transferring the money or doing the transaction the money, which employee is doing well. Okay, so how is the performance on the customers? Okay, so like this, we do have a lot of tables are involved in the data modeling. So if you consider these tables, so countries table, regions table, accounts table, merchant table, so a lot of tables are available. Okay, so in this customer table, so each customer will be identified by customer ID. So this ID we will call it as a primary key in a database. Okay, so then we will have all other information of our customer. So for example, customer name. So customer name might be a duplicated. Okay, so 2 customers may have same name, but the customer ID will be different. The customer mobile number. Okay, we can get the customer mobile number to give them the update. The mobile number, we can get the date of birth of the customer to identify, to analyze the age of the customers. So which type of customers, which age group of the customers is ordering the product. Okay, more. So in order to get that, we need to have the date of birth. So we will get the address of the customers, which location the customer is ordering more, and the city of the customer, and country of the customer. I'm working at different countries. So these are all called the different dimensions. Okay, different dimensions of the customers. So if you consider customer is one of the table, then this is the customer ID is the primary key. So primary key in the sense it will not allow duplicate to the columns. So primary key and customer name, the mobile number, the date of birth is the different dimensions of the customers. This is the dimension table we do have. An employee table the same way, employee ID, employee name, mobile number, employee skill set, employee years of experience, and employee city, address, all those we can get it. The account number will be the primary key, and what is the type of account, what is the active account or inactive account. So different details we can get the accounts. So these are all the tables are dimension tables. Okay, so different dimensions of the data, and by using these dimensions, if I'm going to create a sales, okay, sales, this table is called it as fact table. The sense fact table will have the each key values here, which customer has ordered the product, okay, which employee is helped to purchase the product, employee ID, okay, then which product he has purchased, product ID, then which account number, okay, which account number he has purchased, which region he has purchased the product. So at the end of the day, I want to analyze the summarized data on the regions, which region is performing well, okay, which merchant is performing well. I will have the merchant ID. This is the way I will get all the key values from the table, okay, key values from the table. So these key values are called as foreign keys. Okay, the integrity, to maintain the integrity, we'll have the foreign keys. So normalization, we will see more on the primary key and foreign key, but as of now, we understand this foreign key primary key relationship. So each column is called as foreign key. That is the reference is coming from the base table, the dimension table. So this is like the fact table. We have all the keys we have, and then we do have the quantity, how much quantity he has purchased the product. Okay, for example, 2 quantities he has purchased. What is the one quantity unit price, and what is the total quantity he has purchased or total price. So if two quantities he has purchased, one quantity is $100, then the total price will be $200. Okay, so these three are call it as the measures, the measurable values. These three are call it as the measures. Why? Because these are the measurable values, and these column is called it as the dimensions. So these are like the foreign keys will be maintained in the fact table. This is the fact table. F underscore sales is the fact table. The fact table is derived from the dimension table to have all the customers, information, the employee. We will not keep all the customers information here. Just we will keep the customer ID, which customer he has purchased, which employee has purchased, help to purchase, which product has been purchased, and which account number, from which account he has purchased, which region ID, and which merchant ID, all those. In order to, after that, if I want to get this particular total sales for the day, so even I will use the date key, okay, date ID or date key to have the date. So date dimensions, you will get the date. So which date? So after that, so I will sum of this total price for a particular day, and then I will get the merchant on the ranking, and I will go for the merchant ID, join with this merchant table, and then get which merchant is having the highest sales today. So this is what the fact and dimension tables are related. So again, the data modeling is having the three different types. One is conceptual model, and logical model, and physical model. So what is that conceptual model? So you have concept, okay, you have business concept. Okay, so I want to create a data model for this particular business. Okay, you take the online food delivering the business, okay, online food delivering business. So this is the one of the concept I have as of now. So for this, I want to draw a model, data model. So what are the tables needed for this food delivering uh, particular business? So I will have the time, okay, I will have the date and time dimensions. I will have the product, okay, different product I will have. I will have the different store to purchase the product, all those. So whatever the dimension tables you needed for all the for this particular business, you will draw all the dimension tables like time dimensions, product, store, and regions, and the merchant account, whatever the dimensions you want to have, you have to draw all the dimensions. So with that only name, okay, only name, no need to mention any detailed informations. Okay, so these are called it as entities. Entities is nothing but tables. A technical word is table, but in the conceptual data model we will call it as entity. So what are the entities we are going to have? All the entities we are going to draw. Okay, so includes the important entities and the relationship among them. Okay, so what is the relationship we are going to create? So the tables are like divided into two parts. One is the part is having the primary keys. So whatever the keys you want to have, for example, this product table might have the product ID. The store table will have the store ID. The sales table will have all the foreign keys here. So this is what the conceptual diagram we will write. So here we will not write any attributes. Attributes is nothing but column names. Since it is a conceptual data model, we are not going to write any primary keys, foreign keys, all those. We are just mentioning the entity names and how the entities are related to each other. So this is called a conceptual model. So you can have a simple paper and pen to draw this, or you can have this paint. Okay, so just you can drag and drop all those, and then you can have this conceptual data model. In this conceptual data model, it will be highly abstract. Okay, so it will be highly abstract. So you cannot have any column names. You cannot have any column names. It will be easily understood. Okay, it will be easily understood each and every model. So this conceptual data model will have this highly abstract. Okay, it will not have any attributes names. Attributes name in the sense the field name, the column names. It will be easily understand. You can easily enhance. So you can add more entities to the particular model. Okay, so only the entities are visible. So you should not write any. So it's like a first step of the data model. So we will have all the entities. So only entities we will drop that all the relationship between the tables entities. So no software tool is required to define a conceptual data model. Since it is only the concept, we will no need to have any software tool to draw this. So this is one of the conceptual data model. So time, product, sales, store, regions, account, merchant. So n number of tables can be connected with the fact tables. The fact tables might be connected with different dimension tables as well. So this is called a conceptual data model. Then we have the logical data model. In this logical meta model, it has been enhanced from the conceptual data model. So the first step is we will draw this all the conceptual data model. After that, in this conceptual data model, we will have this what is the primary key we will use. Okay, so definitely each entity we need to have the primary key. For this time dimensions, we will have the date primary key, date key. Then product, it will have obviously it's a product ID. So it is like a description of the column, not the column name, not the exact column name we will write. So simply we will write product ID, okay, with space also. If it is a column name, so definitely if it is an attribute name, definitely we should write with underscore. So since it is a description, so you can write with this, okay. So date descriptions, month descriptions, and year, week, all those. So whatever the attributes you want to have, you can have all the attributes here. In the product table, in the product entity, you can have product ID, product description, category, and category descriptions, unit price, created time, and updated time. You can have all those. And then the sales, the store, right? The store ID, store descriptions, which region is from the store, the region name, created date, updated date, all those you can have it. And then the store, as I told, the upper part of the fact table will have all the foreign keys. So from the store table, you will have the store ID. From the product table, you will have the product ID. From the date, from the time table, you will have the date key. After that, item sold, item amount. I told, right? It will be the measures, only the measures, the foreign keys and measures will be there on the fact table. So item sold is the quantity. Again, the sales amount is the price. So these two are called as measures. Okay, foreign keys and measures will be maintained on the fact table. So this is what we will maintain in the logical data model. We will not write exact column names. We will not write any primary keys and all those. We will simply mention that the column description. It includes all the entities and relationship among them, all the attributes in the sense the column names, all the attributes for each entity are specified. The primary keys for each entity is specified. The foreign keys also identified and specified with this fact table, and normalization occurs at this level. Normalization in the sense, okay, so for example, I do have store table. I'm assuming that in the store table I have the region and region name, okay. So I can split this store table into one more table, okay. Consider this is called normalization. Anyhow, we are going to see tomorrow. So consider this is one more table as the region table we are creating. So the region table we are creating here, okay. And this region table, so we are going to delete these two fields from this table, and here we have only have the region ID, okay, region ID column. So this region ID is connected with this region ID in this table. So this is region ID, we have region ID, so and then region name. So a single dimension table is again splitted into other dimension table to avoid the data redundancy. So how we will avoid the data redundancy? So because if I have a particular store, okay, a particular store in a different regions, okay, so I do have different regions, and in a single region I have multiple store. 100 stores are there in a single regions. So the 100 regions informations will have 100 times the region names will be repeated. To avoid this, we will have only the region ID here, and we will take that region name only one time here, region ID and region, so that the data redundancy will be avoided by using the normalization. So this is called normalization. So normalization occurs this level. So if any possibility of the normalization on the tables, we will split up this table into multiple tables. This is called logical data model. So presence of attributes. So definitely you will have the attributes present in each entity, and the key attributes, the primary key and foreign key, and the non-key attributes, the description you will have, right? The non-key attributes you will have. These are all the non-key attributes. This date is the key attributes. Here the product ID is the key attributes. Then primary key, foreign key relationship. Definitely will have the primary key and foreign key relationship. And user-friendly attribute names. You can have only the descriptions. No need to have the primary key and foreign key. Sorry, no need to have that entire column name. You can have these descriptions, and it will be more detailed than the conceptual model. So you'll have all the column names, right? So Erwin is the data modeling tool, or Power Designer, okay, can be used to create logical data models. So this data model we are going to create, and then this can be automatically converted to a physical data model with the help of this tool. So if you create the logical data model, so only this model, then the Erwin tool will convert this model into a physical data model. Okay, so it will create the table names, all those it will create with the columns. So this is the physical data model. See here. So each and every table will have the column attributes as well as the data type of the attributes and the data length of the attributes. Okay, for example, if you consider this is one of the table, the time table. Okay, so here the table name is mentioned as dim underscore time. So dim is nothing but dimensions. So dim underscore time, dim underscore product, fact underscore sales. As I told, the sales table will be a fact table. So this is the actual format we will give. Okay, so dim underscore store is a dimension table. The dimension tables are connected with the fact table here. So see here we have the all the column names underscore with underscore. Exact column name should be there. Okay, so what is the data type? For example, it is an integer or it is a varchar. So how much is the data length? That is also will be provided here. So detailed the logical model. From the logical model, the physical model will be automatically drawn by using any of the data modeling tool. So we can have the Erwin tool. So if you give this for the Erwin tool, if you give this model, so automatically it will convert that into this model. Okay, this model of data. So fact underscore sales. So definitely it will have the fact tables. So all the foreign keys. Again, it is also integer, then integer and float. So mostly it will have the ID columns, the key columns, and these are dimensions. So see here, the specification of all tables and columns will be maintained in this physical data model. The foreign keys are used to identify the relationship between the tables, and denormalization may be occur. Okay, denormalization is in the sense we will again we have splitted the tables, right? Two tables here might be merge these two tables into a single table. So if necessary, we will do this denormalization based on the requirement. So physical consideration may cause the physical data model, okay, to be quite different from the logical data model. So the physical data model again, it will create, okay, it will differ from each database. If it is Teradata, might be the varchar, it will be okay. The integer, big integer, okay. But if it is at Oracle, the integer might be number, the varchar might be varchar2. Okay, so different databases. So whenever we are having the Erwin date tool, if you create that the logical data model, we should select what is the database we are going to apply this. So if you select Oracle, then based on this particular database, it will convert that logical into a physical data model. So this is the physical data model it will create. Then so entities referred as a tables here. So again, we will call it as, since it is a physical table. So here we are going to make the terminologies as table here. Okay, we will not call this as entity. We will call it as table. Attributes will be referred as column here. So database compatible tables, database again compatible the table names, database compatible column names we need to provide, and database specific data types also mentioned. So difficult for user to understand. So those who do not have any technical knowledge, so they were somewhat difficult to understand. But if they are seeing that, they can able to understand what is this column names. So overall, they can able to understand, but in detail level they could not able to understand. Again, we can create the index, constraint, triggers, all the DB objects with this physical data model. So the create table structure has been created automatically for this physical data model, okay, by using any other tool. And this is what the tool will create the automatically logical data model to physical data model of the different versions. different database servers. Okay, so this is the concept of three different data model.
So let us get to the interview questions. First question that we have is compare a database with a data warehouse. Now, there are obvious differences between the two. For instance, the type of data which is used in databases include relational or object-oriented data, while in data warehouse, since we are getting data from multiple sources, we have a large volume of data as well as multiple data types. For the data operations aspect, databases deal with transactional processing, while data warehouses deal with data modeling and analysis. The dimension of data in databases is two-dimensional because we are dealing with tables, which are essentially 2D arrays, while in data warehouses, we can have multi-dimensional data. They could be 3D, 4D. Data design. Databases have ER-based and application-oriented database design, while data warehouses have stars, snowflake schema, and subject-oriented database design. The size of data in databases, traditional databases, not big data databases, is small. Usually, in the maximum, they are in the gigabytes, while in data warehouses, they are in the terabytes. Functionality for databases, it's high availability and performance. With data warehouse, it's high flexibility and user autonomy because we are going to be performing a lot of analysis with the data warehouse. Moving on to question number two, what is the purpose of cluster analysis and data warehousing? Now, one of the purposes of cluster analysis is to achieve scalability. So regardless of the quantity of data, we are able to analyze it. Ability to deal with different kinds of attributes. So no matter the data type of the attributes present in the data set, we are able to deal with it. Discovery of clusters with attribute shape. High dimensionality, which means we can have multiple dimensions, more than 2D to be precise. Ability to deal with noise. So any inconsistencies in the data, we are able to deal with that, and interpretability. Moving on to question number three. What is the difference between agglomerative and divisive hierarchical clustering? So agglomerative hierarchical clustering method allows clusters to be read from bottom to top so that the program always reads from the subcomponent first and then moves to the parent in an upward direction, whereas divisive hierarchical clustering uses top to bottom approach in which the parent is visited first and then the child. An agglomerative hierarchical method, it consists of objects in which each object creates its own clusters, and these clusters are grouped together to form a larger cluster. It is also the process of continuous merging until all the single clusters are merged together into a complete big cluster that will consist of the objects of the child clusters. However, in divisive clustering, the parent cluster is divided into smaller clusters and it keeps on dividing until each cluster has a singular object to represent. Moving on to question number four. Explain the chameleon method used in data warehousing. So, chameleon is a methodology which is a hierarchical clustering algorithm that overcomes the limitations of the existing models and methods in data warehousing. This method operates on the sparse graph having nodes that represent data items and edges which represent the weights of the data items. This representation allows large data sets to be created and operated successfully. The method finds the clusters that are used in the dataset using the two-phase algorithm. The first phase consists of the graph partitioning that allows the clustering of the data items into larger number of subclusters. The second phase, on the other hand, uses an agglomerative hierarchical clustering algorithm to search for the clusters that are genuine and can be combined together with the subclusters that are produced. Moving on to question number five, what is virtual data warehousing? Now, a virtual data warehouse provides a collective view of the completed data in that warehouse. A virtual data warehouse has no historic data. It can be considered as a logical data model of the given metadata. The virtual data warehousing is the de facto information system strategy for supporting analytical decision making. It is one of the best ways for translating raw data and presenting it in the form that can be used by decision makers. It provides a semantic map, which allows the end user as well for viewing as the data is virtualized. Moving on to question number six. Now we need to understand what active data warehousing is. An active data warehouse represents a single state of a business. Active data warehousing considers the analytical perspectives of customers and suppliers.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
It helps deliver the updated data through reports. Now, this is the most common form of data warehousing, which is used for businesses, large businesses in specific, which deal in the industry of e-commerce or commerce. A form of a repository of captured transactional data is known as the active data warehousing. Using this concept, trends and patterns are found to be used for future decision making. So, based on the analytical results that you get from the data warehouse, you can perform further business decisions. Active data warehouse as a feature which can integrate the changes of data while scheduled cycles refresh. Enterprises utilize an active data warehouse in drawing the company's image in a very statistical manner. So everything essentially you get a combination of all the data that is present in various data sources, you combine it all together, and then you perform some analytics on it to get insights for further business decisions. What is a snapshot with reference to data warehouse? Now, snapshots are pretty common in software, especially in databases. So essentially, it is what the name suggests. Snapshot refers to the complete visualization of data at the time of extraction. It occupies less space and can be used to backup and restore data quickly. So you essentially snapshot a data warehouse when you want to create a backup of it. So using the data warehouse catalog, you're creating a report and the report will be generated as soon as you disconnect from the data warehouse. Number 8, what is XMLA? XMLA is XML for analysis, which can be used and considered as a standard for accessing data in the OLAP method, data mining, or data sources on the internet. It is the simple object access protocol. XMLA uses discover and execute methods. Discover fetches information from the internet, while the execute allows the application to execute against the data sources that are present. XMLA is an industry standard for accessing data in analytical systems such as OLAP. It is based on XML, SOAP, and HTTP. XMLA specifies MDXML as a query language. In XMLA 1.1 version, the only construct is the MDXML in an MDX statement enclosed in the tag. Moving on to question number 9, what is ODS? Now, ODS is the database which is designed to integrate data from multiple sources for additional operations of the data. The full form of ODS is operational data source. So unlike the master data source that you have, the data is not sent back to the operational systems. It may be passed for further operations and to the data warehouse for reporting. In ODS, data can be scrubbed, resolved for redundancy, and checked for compliance with the corresponding business rules. So whatever data you have, in order to filter it out basically, to see if there is some data redundancy in the data, it is checked, and it also sees whether the data is compliant with the organization's business rules. This data can be used for integrating disparate data from multiple sources so that business operations analysis and reporting can be carried out. This is the place where most of the data used in the current operation is housed before it's transferred to the data warehouse for longer term and for storage and archiving. And ODS is designed for relatively simple queries on small amounts of data, such as finding the status of a customer order. So you have a data warehouse which is present to you. Say, for instance, for a particular customer ticket, you need to find information with regards to a customer, then you can use the ODS rather than the complex queries on large amounts of data typical of the data warehouse. So you're not going to be running it on the entirety of the data, which will take a lot of time to find a single customer's details. You would rather use ODS for that matter. And ODS is similar to the short-term memory where it only stores very recent information. On the contrary, the data warehouse is more like a long-term memory storing relatively permanent information because you're creating a data warehouse for a permanent basis. What is the level of granularity of a fact table? A fact table is usually designed at a low level of granularity. This means that we need to find the lowest of information that can be stored in a fact table. For example, employee performance is a very high level of granularity, while employee performance daily and employee performance weekly can be considered as low levels of granularity because they are a much more frequently recorded data. The granularity is the lowest level of information stored in the fact table. The depth of the data level is known as granularity. In date dimension, the level could be year, month, quarter, period, week, and the day of granularity. So the day being the lowest level, the year being the highest level. The process consists of the following two steps: determining the dimensions that are to be included and determining the location to find the hierarchy of each dimension of that information. The above factors of determination will be resent as per the requirements. Moving on to question number 11. What is the difference between view and materialized view? Because the name suggests that now view simply means the rate table data representation that is provided with a view to access the data from its table that does not occupy space, and changes get affected in the corresponding tables. While in materialized view, pre-calculated data persists. It has physical data space occupation in the memory, and changes will not get affected in the corresponding tables. What is junk dimension? In scenarios where data may not be appropriate to store in the schema, the data or attributes can be stored in a junk dimension. The nature of the junk in this particular dimension is usually Boolean or flag values. A single dimension is formed by lumping a small number of dimensions. This is called a junk dimension. A junk dimension has unrelated attributes. The process of grouping these random flags and text attributes in a dimension by transmitting them to a distinguished subdimension is related to junk dimension. So essentially any data that need not be stored in the data warehouse because it is unnecessary is stored in the junk dimension. Moving on to question number 13. What are the different types of SCDs used in data warehousing? SCDs are also short for slowly changing dimensions. They are the dimensions in which the data changes slowly rather than changing regularly on a timely basis. There are three types of SCDs. The first is SCD1. It is a record that is used to replace the original record even when there is only one record existing in the database. The current data will be replaced and the new data will take its place. SCD2, it is the new record file that is added to the dimension table. This record exists in the database with the current data and the previous data that is stored in the history. SCD3, this uses the original data that is modified to the new data. This consists of two records, one record that exists in the database and the another record which will replace the old database record with this new information. Moving on to question number 14, which one is faster, multidimensional OLAP or relational OLAP? Now, multidimensional OLAP, also known as MOLAP, is faster than relational OLAP because of the following reasons. In MOLAP, the data is stored in a multidimensional queue. The storage is not in the relational database, but in proprietary formats. One, for example, is Power OLAP, which is the of the extension .olp. MOLAP products are compatible with Excel, which make data interactions easy to use even for non-technical members of a team. Enrollup products access a relational database by using SQL, which is the standard language that is used to define and manipulate data in an RDBMS. So, since Rollup is not accessible by simple programs like Excel, you need to know SQL in order to be able to query that data. That is why it's not as compatible with people who don't have that much technical knowledge. Subsequent processing may occur in the RDBMS or within a mid-tier server, which accepts requests from clients, translates them into SQL statements, and passes them to the RDBMS. So, due to multidimensional OLAP using a proprietary file format, it is faster than relational OLAP. Moving on to question number 15. What is hybrid SCD? Now we discussed SCD 1, 2, and 3 earlier on. Hybrid SCDs are combinations of both SCD 1 and SCD 2. It may happen that in a table some columns are important and we need to track changes for them, that is, capture the historical data for them. Whereas in some columns, even if the data changes, we do not need to bother. For such tables, we implement hybrid SCDs, wherein some columns are of type 1 and some are of type 2. So basically, we are not applying a blanket rule on the entire table. We can customize on which particular columns we want to apply what rule. Moving on to question number 16. Why do we override the execute method in struts? So as parts of the struts framework, we can develop the action servlets and the action form servlets and other servlet classes. In the action form class, we can develop validate method. This method can return action errors object, and in this method, we can write the validation code as well. If this method returns null or action errors with the size of 0, the web container will call execute as part of the action class. If it returns size greater than 0, it will call the execute method. It will rather execute the JSP servlet or the HTML file as the value for the input attribute is part of the attribute in the struts config XML file. Question number 17. What is VLDB? So VLDB stands for Very Large Database, and it is a database that contains an extremely large number of tuples or rows, or occupies an extremely large physical file system storage. 1 terabyte database would normally be considered as VLDB. Question number 18. How do you load the time dimension? So time dimensions are usually loaded by a program that loops through all possible dates appearing in the data. It is not unusual for 100 years to be represented in a time dimension with one row per day. Question number 19. What are conformed dimensions? So conformed dimensions are the dimensions which can be used across multiple data marts in combination with multiple fact tables. A conformed dimension is a dimension that has exactly the same meaning and contents when being referred from different fact tables. It can refer to multiple tables in multiple data marts within the same organization itself. Question number 20. What is the main difference between Inmon and Kimball philosophies of data warehousing? So these are two philosophies that we have in data warehousing. So in the Kimball philosophy, data warehousing is viewed as a constituency of data marts. So data marts are focused on delivering business objectives for departments in an organization, and the data warehouse is a conformed dimension of the data marts. Hence, a unified view of the enterprise can be obtained from the dimension modeling on a local departmental level. And in the Inman philosophy, we can create a data warehouse on a subject by subject area basis. Hence, the development of the data warehouse can start with the data from the online store. Other subject areas can be added to the data warehouse as their need arises. Point of sale or POS data can be added later if management decides that it is required, and if we can look at it on a sort of algorithmic basis. In the Kimball philosophy, we first go with data marts and then we combine it and we get our data warehouse. While with Inman philosophy, we first create our data warehouse and then we create our data marts. Question number 21. What is the difference between a data warehouse and a data mart? So we understood both of the philosophies in the previous slide. Let us now understand the actual difference between a data warehouse and a data mart. A data warehouse is a set of data isolated from operational systems. So it is basically away from the database itself. It is a view of the database. This helps an organization deal with its decision-making process. A data mart is a subset of a data warehouse that is geared to a particular business line. Data marts provide the stock of condensed data collected in the organization for research on a particular field or entity. So this is basically stating that the data warehouse contains a whole variety of information, while a data mart is just a subset of that information based on a particular business line or model. So basically say you have a data warehouse that is based on customer and sales data. You can create a data mart that is purely based on transactional data with the combination of those two data lines. Instead of getting the entirety of the customer and sales data, you're just getting the data that is relevant to your transactional data set. The second difference is a data warehouse typically has a size greater than 100 gigabytes, while the size of a data mart is less than 100 gigabytes. Due to the disparity in scope, the design and utility of data marts are comparatively simpler. So naturally, since data marts are subsets of data warehouses, their size is less as well. Question number 22. Explain the ETL cycle's three-layer architecture. Now, as we all know, ETL stands for extraction, transformation, and loading. So there are three phases involved in it. So the first is the staging layer, and then we have the data integration layer, and then we have the access layer. So these are the three layers that are involved for the three specific phases in the ETL cycle. So in the staging layer, it is used for the data extraction from various data structures of the source. In the data integration layer, data from the staging layer is transformed and transferred to the database using the integration layer. The data is arranged in hierarchical groups, often referred to as dimensions, facts, or aggregates. In a data warehousing system, the combination of facts and dimension tables is called a schema. So basically, once you have the data extracted in the staging layer, you're basically transforming it in the data integration layer. And finally, you have the access layer where the data is accessed and can be loaded for further analytics. Question number 23. What does data purging mean? So data purging, the name is quite straightforward. It is the process involving methods that can erase data permanently from the storage. Several techniques and strategies can be used for data purging. The process of data purging often contrasts with data deletion, so they are not the same. Deleting data is more on a temporary basis, while data purging permanently removes the data. This in turn frees up more storage and memory space which can be utilized for other purposes. The purging process allows us to archive data even if it is permanently removed from the main source, giving us an option to recover that data in case we purge it. The deleting process also permanently removes the data but does not necessarily involve keeping a backup. It generally involves insignificant amounts of data. Question number 24. What are the five main testing phases of a project? So the ETL test is performed in five stages, which are the following. The identification of data sources and requirements. So first, you'll identify which data sources you want for your data warehouse and what is the requirement of the data warehouse and the analytical requirements that your organization needs. The acquisition of data, naturally, after identifying the data source, you will acquire that data, implementing business logic and dimensional modeling on that data, building and publishing that data, and the reports that you'll create out of the analytics that you perform. And finally, question number 25, what do you mean by the slice action? How many slice operated dimensions are used? So a slice operation is the filtration process in a data warehouse. It selects a specific dimension from a given cube and provides a new subcube. In the slice operation, only a single dimension is used. So basically, out of a multi-dimensional data warehouse, if you need a very specific dimension that you need for further analytics or processing, then you'll use the slice operation in that data warehouse.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below.